When you're getting your brick saw, the legs will be off because we'll have it down onto a pallet. Take the legs out, and when you need to install these, of course you're going to lift one end up over the other. Put the legs so that they're facing out on the sides. They have a little bit of dog leg on them. That kind of spreads the load out further and gives you a lot more stability. When you first get these brick saws, you will get them on a pallet and the legs will be off. You'll have to put the legs in and they go through here. You have clamps here. These clamps will help adjust the legs up and down. And when you're placing them in your building, you do want to find at least the flattest ground of concrete or whatever tile that you're putting it on. So it's very important that you don't load one of the legs over the other, because that can often throw the alignment of the saw. So it's best if you have a straight edge like this and a bubble leveler that you can put across your saw and check that the bubble is between the two hairlines. And so I would do this to the front and to the back, and you can also lay it here on the side railing and make sure that you're level here. However, you could probably raise this up slightly, have the bubble maybe come up towards the right of the hairline on your leveler. That'll help give you a little bit of slope so that when you have to drain the basin here, it can go down through the hole in the back and down into a bucket. To adjust them, of course, you need to at least find out which leg is not carrying the load or which one is, and of course loosen this up, lift up on it a little bit, kind of look at your leveler at the same time, like right here, and kind of work it around so that you've got, you know what's going on the saw. Because if this thing does rock, you will have the saw blade probably getting closer to one of these V uprights that hold your specimen in here. Now that we've established that the table here on the tray is level to the floor, you'll want to run this back and forth, your fixture, and see that it is also square running on the rails here. You may find that you have a little bit of play. These wheels here on the right side, if you're cutting 50 millimeter, are the smooth wheels. These wheels have a cam on them, and you can adjust that cam so that you've got all four wheels and no play side to side like this, running back and forth. This wheel is here, what I'm talking about, that has the cam on it. It's the smooth wheel. If I take these washers off the back side, you can see there's an offset in the bolt. So these bolts here, that's a 13 millimeter, and then the cam itself is a 15 millimeter. In the back side, you'll have another 13 millimeter. So loosen these up from torque. Just keep them snug a bit. Then come in with your 15 millimeter and holding the back side with the bolt behind the plate there with another 13 millimeter. In my case, I don't have a 15 millimeter. I have this metric wrench. So go in here and just run that back and forth until you feel you've got good contact on the rail. And that should get their fixture running smooth back and forth. On your brick saw, you may find that the specimens you're cutting have been out of spec. Say you've got a 50 millimeter sample that you're cutting and you're 52, and 52 on one side of the sample piece as you're measuring that 6-inch diameter with a caliper, and you might have 48 on the other end of it. across the diameter. So you may want to check to see that your blade is parallel to your table here. So I've taken the cradle top plate off of our fixture here and just working on the base. So I slide that in here, and I've got a machinist square here, and I put that down on the base, and I put it right up against the saw blade in between the serrations here, because that is a raised edge on there, and I want to get the blade here. So then I put a flashlight in there, and I go up and down, see if there's any light. If there's a gap down here, say it's like this, you need to adjust it. And to do so, we have 2 carriage bolts back here on a pillow bearing, and the shaft that goes through here. You can loosen these. This is 11/16 nuts on here, and loosen them, not too loose, just kind of keep them so that now you've got a little bit of movement. These are slotted here, and you can move the shaft of this saw blade up and down. And of course, if we have a gap on the bottom like I was showing you here, you'll need to move these carriage bolts in the pillow block up, and there's an adjustment screw right here. That's 9/16, and you just turn that up, and that works against the pillow block and brings that up. To check your parallelism with the saw, you'll want to take your machinist square and place it on the rolling table here, put it up to the back of the saw blade right at that point, and run it forward, and see that you have a gap here, or if it's touching, that means you've got a good parallelism with the saw. Also, start from the start here again and run it to the back and see that you have a gap or not. Now it might have bounced here. Sometimes you need to hold it if you got something flimsy, but touch the blade, run it back, and it looks like there's a gap there. You'll want to go on the far side of the pillow block there and make the adjustment to bring the back end of the saw blade into the square. Now the blade is not always perfect, so there would probably be a little bit of wobbling. You may want to check that. Take the blade and run it 90 degrees and go ahead and do the process over again and see if you have a little bit of difference. So there's a little bit of bearing that goes on with it. If you do this, at least it'll give you a better track as you cut across your sample piece. Okay, to run the blade so that you need to move the blade either towards me or away from me to make sure that you're within the cradle gap that we've got here and you're not cutting into the aluminum. There's one other aspect of aligning these, and on this shaft here that carries the pivot arm of the saw, in these pillow blocks here, you've got these stays that keep this thing from moving back and forth. If you need to do that to get this thing aligned, you've got a 3mm Allen wrench here, you've got 2 set screws, and you need to loosen those up, 1 and 2. On the far side you have them as well, however they're a little harder to reach because you have the belt guard on that left side, but you'll have to manage. Usually I'll take an Allen wrench, and if I got a tight spot, I'll take a crescent wrench, clamp it on the L part of the wrench. You get a little more leverage there, and you can crank them loose. Now, some guys are going to love this. It's a dead blow hammer, and I don't strike this. What I do is you want to strike the carriage that is on the motor here to at least knock it over to where you feel you're probably within range. So on that right side here, you did loosen those two clamps on the collar from the pillow block shaft. You do that as well with these. Like I say, they're a little hard to get to, but I've done it. Anybody else can do it. And so now that you've got these loose, you've got the dead blow hammer here. Now you're not going to get any movement until you take the preload off of the spring here. So loosen this blade up, bring it up all the way so that it's loose some. Take your dead blow hammer. Again, you don't hit the columns. What you do is you want to hit the shaft or the carriage part of it. Just give it a good whack on a flat place here. If you're afraid about marring it, use some cardboard or whatever. I'm sure you're not going to, because it's going to be pretty grungy the first time you cut it. You have the core samples that you want, be it out of a gyratory. You place this sample here into the cradle, making sure that your surfaces are all clean. Center it, and then with these angles here, you want to give it sort of a light pressure on it. The sample itself will stay in this cradle on its own, and this is kind of an added security. You don't really need to torque on these handles. And as you draw this through, you can make your cut. Actually, I would tell you to start probably doing the outers first, and you can slide this over and place it, your tapered handles, into the slot like so. Draw it through, make your cuts on both ends, and then end up in the middle, and you'll have two 50mm width samples for testing. This also covers the 62 width samples, and so if you take your cradle off, if you can see here, we've got written on 50, and that's the setup where we just previously had. Then just take your table, flip it around, make sure your wheels are in the groove, as so on the rails, and you have your 62mm samples.